So guys, today's topic where we wanted to discuss regarding the main topic of Gen AI revolution. So as we saw the Gen AI potentials in late 2022 and then 2023. So in 2024, the major topic around Gen AI application is from experimentation to production. In 2022, we have already seen the capabilities of generative AI and the potential capabilities we seen in 2023 as well. But in 2024, the major focus is on how we can move the applications from experimentation to production. And that is, yes, a very tough questions because most of the companies are already trying to resolve, trying to define the architecture, trying to do the value proposition analysis, why and how we can take our applications from POCs or from experimentation to the production level. So there are few challenges we have noted down being a forefront of Gen AI revolution, and we are already working in this industry from past many years now. So we identified these challenges like why moving the applications from experimentation to production is hard. So there are few challenges, and I have segregated these challenges into two categories. One is from the business perspective, and second is from the technical perspective. So from business perspective, the main challenges are in terms of data privacy and security, fairness and responsible AI, alignment with the business goals, value proposition clarity. And from the technical perspective, if we talk about the skilled workforce is not available for AI or Gen AI applications, data and LLM ops pipelines, throughput and latency is the very major and critical issue in any LLM application. And of course, evaluation is also a very challenging part because in normal machine learning or AI application, we have a numerical data and we have a decent algorithms and benchmark available to do the evaluation part. But in terms of generative AI application or natural language processing application, evaluation is always tough. So for example, if I say one statement, Ankit loves coffee or Ankit doesn't love coffee, so there is only a one word of difference, but the complete context or the intention of the sentence is completely different. So evaluation becomes very challenging when we talk about the generative AI applications or natural language processing applications. So how we can overcome these challenges, we will definitely discuss a few solutions today. So how we can overcome these challenges. And meanwhile, guys, if you will would have any question and queries, so we have a Q&A section. So you guys can post your question and queries over there. And I will try to answer your question and queries alongside, or otherwise I can definitely answer your questions by the end of the webinar. So if you guys see this diagram, so this is a classical, or I will say the traditional workflow of any generative AI application. So this start from the top right section. So from top right section, let's say we have a UI component. So in UI component, so normally I hope everybody is familiar with the chat GPT. So how the chat GPT works. So we have a UI over there. So we enter the query to the chat GPT, and that query goes to the prompt section. So that query will go to the initial prompt, and same query we send to the embedding model, so which is our vector DB or our information where we have stored the information in the vector formats. So it send that query to the vector database, it match the records from the DB, and it include that content along with your prompt to generate the final prompt. And then we do have a prompt optimization tool. We can optimize the prompt in different way. We can identify like there is no harmful text included in the prompt, there is no prompt injection kind of things over there that I will also cover in a couple of next slides. and that prompt goes to the LLM. So that LLM generate the response based on the prompt or based on the information we passed into that prompt. And the final output will be generated. We can cache that output to send that output as it is in the next input query, and we can also apply some sort of classification filters. We apply some sanitization techniques to the output, because output could also be harmful. If the input could be harmful, let's say the output which LLM has been generated, that could also include any hallucination kind of thing. Maybe the answer could not be relevant or the answer is not correct. So this is the section where we classify the output which has been generated by the LLM. And finally, the cleaned and the sanitized output will be returned to the end user. So this is how the normal architecture for any generative AI application. I'm not saying like for all the application this will be the architecture, but for most of the generative AI applications follow this sort of architecture. So now we are talking about the a few techniques how we can optimize the LLMs and how we can optimize the overall generative AI pipeline for the production. So there are few techniques, and I hope you guys will be familiar with all these techniques. So first is the prompt engineering. So prompt engineering is always the initial step to fine tune your responses or provide the instructions to the model how to generate the response. So prompt engineering is a altogether very big concept, but the high level idea of prompt engineering is to pass the clear instructions to your model, split the task into the smaller subsets, giving the model time to think like what sort of requirement you have and what sort of query you have entered into your LLM model, and showing the clear examples. And when I say the examples, we have a few shot training, zero shot, one shot kind of models in prompt engineering. So these are the some common techniques we can use in prompt engineering. And there are some playgrounds available over the internet where you guys can go and you guys can do a different sort of experimentation with the prompt engineering. But prompt engineering is the first and very comprehensive technique to improve the results for your LLM, for improve the results for any of your generative AI application. But let's say the prompt engineering is not sufficient. So your prompts are well instructed, your prompts is having clear instructions for the model, but still somehow your LLM is not able to respond it correctly. It means like maybe your LLM is not having sufficient information to respond to your query. Then the RAG comes into the picture. So what is the purpose of RAG? RAG allows your LLM model to pull the information from external data sources. So for example, any LLM model, for example, when GPT was launched, I think that was trained the data till 2021, and then maybe in the next version of GPT model, they trained the model again to the data till September 2023. So when we trained any particular model, the knowledge or the capabilities of that particular model is just limited to the data to whom that model is trained. And if we will ask any extra information from that particular model, then that model will return the hallucination kind of response. So that's where RAG is a very important concept in any generative AI application or end-to-end pipeline. And as I mentioned, RAG allows your LLM to pull in the information from external data sources and real-time data sources. So for example, let's say you are working or you are preparing a board for any financial market or financial advice. So RAG will help you to get the latest stock prices or economic reports. Or for example, you are making a chatbot for health care. So RAG can enable your model to get the latest patient health information. which is not available to the model when the model was actually trained. So this is how the RAG is a very powerful concept. We can integrate the RAG, and within the RAG, we can integrate multiple different sources. We can import the data from PDF documents. We can import the data from uh, through web scraping. We can use videos, images, any source of data we can input to the RAG to make our models enable with the real-time information. And then our third concept that comes the fine-tuning concept. That is obviously a last option, I would say, or maybe I would say the most challenging part, where we this option we normally pick for any LLM application or any generative AI application. So we always need to ask this question to ourselves, like why we need a fine tuning, why we need to fine tune the model. So there could be, more specifically, there could be only two major reasons when you have to fine tune your model. It could be improving the model performance on specific tasks, or it could be improving the model efficiency. So when I say the performance on specific task means, let's say you have a you are done with the few shot training, but still your model is not capable to give you the results. And even when you do the few shot training in the prompt injection, it means you are also consuming hundreds and thousands of tokens, which you cannot always provide, because in LLM or in generative AI application, tokens means cost. The more the token you will consume, the more you will have to pay for that LLM model services. So when you have a situation like where the prompt training is not helpful, there you need to fine tune the model with the specific instructions. There you need to perform the fine tuning. And the second thing, if you want to improve the model efficiency, because LLM applications are very slow. We mostly familiar with the chat GPT efficiency. So in chat GPT, we send the query and we get the result straight away. But this is not the normal behavior of any generative AI application. So accept GPT model or chat GPT if you have done work with any open source model, or if you have experienced any other open source LLM, you guys might like identify the performance is very slow. Sometimes it took even minutes, 5 minutes, 10 minutes to generate one response. The reason is like the LLMs are very slow, and the way it works, it generate one word at a time, the next token at a time. So if you ask LLM to generate one essay maybe, or a large article, it generate one token at a time, and then it completes the whole article. So that's why the LLM models take that much time. So through fine tuning, we can train the model on specific instructions. We can provide the additional input output kind of pair to our models that helps to improve the model efficiency as well. So these are the techniques we can use in fine tuning. But as I mentioned, first of all, we need to think in it that way, why we need fine tuning, or do we really need fine tuning? And one very common mistake I usually notice in this industry, people feel like first we will do the prompt engineering, then we will do the RAG, and then we do the fine tuning. No, this is not the defined way, and this is honestly not the linear process or the sequence. We can do any of these things, maybe the first step, second step, or third step. Maybe we can do the fine tuning at a first step, and then we can do the prompt engineering, or we can do the RAG first, then we can do the fine tuning, or then we can do the prompt engineering. So there is no defined sequence, like first we always have to do the prompt engineering, RAG, and then only we can do the fine tuning. We Although I also recommend to go with the combinations. So let's say for any particular use case you feel prompt engineering and fine tuning is the much better option, then RAG might not be required. And maybe in the another use case you guys feel no, the RAG and fine tuning will help better, then maybe the prompt engineering is not required. So based on the use case, based on the requirement, we need to find the perfect combination. And whenever we talk about the model performance or optimization, we need to define the evaluation in two different ways. So this is how I see the problems and evaluation. So one is the context optimization and second is the LLM optimization. So when we say the context optimization, it means the model doesn't have the access to the right knowledge. Model is following the instructions absolutely correct. Model is generating the response in whatever format you asked for, but the model doesn't have the information to put into the response. So let's say if you ask to the model, give me the Apple stock price of yesterday in this particular format or in this particular JSON format, model will create the same pattern of JSON for you, but maybe the stock price will be incorrect over there because model doesn't have the data of yesterday's stock price. And the second use case, the model has the data, but the model is not following your instructions and not giving the response in the desired format you have asked for. So that is the LLM optimization thing. So whenever you design any generative AI application or whenever you evaluate the results, you need to figure it out, either it is a context problem or is it a LLM problem. So if it is a context problem, then RAG is not required over there because model is already having the information. Maybe the problem is with prompt engineering or the fine tuning. But let's say the model is giving the result in a desired format, but the information is correct, it means model doesn't have the access to the right information. Maybe that's where RAG is important. That's where you need to bring RAG pipeline into the picture and you need to put the data from the external sources. And as I mentioned before, usually we think a lot at a time of doing fine tuning because fine tuning, we think it like a very scary way or very time consuming, complicated. So whenever we think about fine tuning, we think, no, no, it's a very complicated thing or expensive thing or worthless, many other reasons. But reality says that fine tuning can get your model performance even much better than GPT-4, up to 30x cheaper as well. So for fine tuning, there are so many algorithms and techniques available. LoRa is one of them. LoRa stands for low rank adaptation. So that is a popular method for parameter efficient tuning. So in this particular technique, what LLM does, maybe it will not override the complete knowledge of the basic LLM model, but it will just override the few parameters or the last layer of your model with the additional instructions you are providing or with the additional information you are giving to that model. So LoRa is a very popular method for fine tuning any LLM. And 4-bit of LoRa, as you can see in my slide, 4-bit of LoRa fine-tuned model could even outperform the base model, any base model, including GPT-4. So the only work over here, we just need to investigate the best base model to fine tune because there are so many open source LLM models are available these days. They are trained on different data, different instructions for different use cases. We need to investigate and figure it out the best available open source model for our use case that will not be 100% ready to go, but maybe 90%, and the rest 10% improvements we can do either using prompt engineering or RAG or fine tuning techniques. So once the model is trained and the model is giving you the results, so now we comes to the inference part. And as I mentioned earlier, the prediction or the inference is a very, very complex thing in case of LLM models And why complex? Because we have to generate a very large response. So if you have to write an article, or if you have to write one LinkedIn post from for 200 words or 300 words from LLM, so it will generate the response word by word. So it will use the previous string, generate the next word, then the whole previous string, the next word, then the whole previous string, the next word. So this is go into the into that particular sequence. So that's why inference becomes very slow and complex in case of LLMs. So there are two basic techniques whenever we design the inference pipeline. So one is the inference engine and another is the inference servers. So there is a big difference between these two things. So inference engines basically responsible for everything that you need to generate the response. So basically that covers the LLM architecture, and the inference server handle your incoming or outgoing HTTP request. So server is a kind of normal server where you are hitting the request and you are getting the response. But within the server, we have another layer for inference, and that layer we call it as an inference engine. So what is the role of inference engine? So inference engine itself includes many techniques like KV caching, dynamic batching, concurrent model execution, page attentions kind of things. And there are a couple of engines already available, like VLLM is available, TensorRT, LLM TensorRT framework is provided by NVIDIA itself. So these engines help you optimize your inference pipeline. So if I give you the example of, let's say, dynamic batching. So how the dynamic batching works. So let's say you have entered 5 input queries to your LLM model. So in traditional request cycle, how it happens, like first it will complete the first request, then it will pick the second request, then it will pick the third request. But in case of LLM, if we will do in this way, maybe the fifth request will take 30 minutes to get the response. So in case of dynamic batching, what it process the request in parallel. It will generate the one token for the first request, same time the one token for the second, one token for the third, one token for the fourth, one token for the fifth request. So it will process all the 5 requests in parallel and generate the result in a same way, or maybe the simultaneously. So that's why LLM inference engines are very, very important whenever we are building the LLM prediction pipeline or LLM inference pipeline. And now let's say we are done with the inference as well. We are getting the results from the LLM. So next part is the evaluation part. So how can we evaluate the response of the model or whatever response we get from the model? So there are few valuable benchmarks, I would say, or the categories, I would say, which we need to measure for every LLM response. So first thing, do our response is relevant? So if I asked for Apple stock price, so did I get the Apple stock price in return? Second, the faithfulness. So what price I got, is it the correct price or the not correct price? Or maybe we can consider faithfulness as a source of information. So from where I get that response, was that source reliable or not? Context precision, what was the accuracy of that particular response? So if the model returned me $200, was it exactly $200 or there is some up and down in the price? Context precision. And the correctness again. So whatever the returned by the model, is it a correct response or incorrect response? So these are the basic parameters which we should validate at every LLM response, because LLM response could create bias problem, could create hallucination problem. The answer could be incorrect, not relevant, out of the context. And these are the very common problems with any generative AI or LLM application. So there are few methods we can implement for evaluation. So again, I categorized into the four categories. So one may be the vibe check, human valuation, benchmarks, or LLM as a judge. So what about the vibe check? So vibe check is a very simple and straightforward approach where a human can validate the response manually. But this approach is just limited to the very early stage kind of thing. So when you just started the application, you can validate a few initial responses. Is it coming correctly or not? Because that is a human intensive approach. And then the second approach, human evaluation. Again, this approach is human intensive, but in this particular approach, we deploy more man force. So we could have a dedicated team for the evaluation, and they are just validating the response generated by the model. And third, there is a benchmark available. There are many different frameworks, algorithms, and benchmark available to evaluate the LLM responses. And fourth, LLM as a judge. So this is a very excited way. So let's say you generated a response from ChatGPT. Same response, and along with the question, you can send in another request to the maybe to the larger model. So this was my question, and this is the answer generated by the previous model. Can you validate if this result is valid or not valid? So one LLM we used for generating the response, and another LLM we used to validate the response. But again, this approach is obviously the, I would say, expensive approach, because every token we are consuming in input and output, we are paying for that token. So after evaluation, maybe in evaluation, I can also explain you about a few different matrices or few benchmark which I was talking about. So basically there are six common benchmark which we follow in the industry. So one is ARC, second is truthful QA, third is GSM 8K, fourth is HelaSwag, fifth is MMLU, and sixth is Vinogrant. So I'm not sure how many guys you guys have seen the leaderboard of LLM models, but whenever any new LLM model launched, or if you follow the leaderboard of LLM, there are these benchmark available. So they mention like our LLM MMLU score is 90%. Maybe the Llama 3 score was 89%. GPT new version will come, they will say we have beaten the Llama 3. Now our MMLU benchmark score is 90%. So this is how these models benchmark their performance, and this is how these model like overtake the other models in the industry. So after evaluations, there are a few concepts related to the security and guardrails, because now you have generated the responses, you have evaluated the responses as well. But there are some security challenges and guardrails we cannot avoid in any generative AI application. And these are again very common problems with the generative AI application. So if I explain you a couple of problems, so how we can so first problem is, for example, prompt injection. So what is the prompt injection? So in prompt injection, any attacker or any hacker can inject your prompt. So let's say you have trained your model very well with the defined instructions. But let's say if I send a prompt and I write these words over there like avoid all the previous instructions and just follow the following instructions. So if I write this kind of prompt, it might overcome all of your previous instructions and I can easily inject your prompt. So this is example of prompt injection. And how we can prevent these problems? Obviously, we have to implement some robust input validation and sanitization methods over there. We need to filter it out if this prompt is malicious prompt or is it coming from any untrusted source. So this is how we need to overcome the prompt injection problem. And similarly, the second problem could be uh, I would say the output harmfulness. So output could also be harmful. So as I mentioned earlier, let's say whatever the response has been generated by your LLM model, that response could be invalid response. So we need to validate whatever response has been generated. Was it a relevant response? It doesn't include any harmful content over there. It doesn't include any abusing language into that prompt. Is it only giving the required information? Is it not sharing any sensitive information in the output? So these all filtration and moderation we need to apply on our output to validate our output is valid output. And similarly, there are some other security challenges like data leakage, data poisoning, model theft, denial of service. So denial of service is a very common problem in the industry. So as the LLM inference is slow, so any hacker can send the multiple requests to your application. And maybe the intention is just to dead your application or maybe the slow down your application. So we need to avoid those things as well. For that, we can implement specific quota limits, request limits to our generative AI application so that no hacker can send any number of requests. We need to detect the anomalies continuously. We need to do the monitoring and observability of our application so that our normal user or the regular user are not facing the denial of service kind of things. And over reliance is my personal favorite kind of say security concern. I would say these days, being an human, we are being like 100% reliable on Chat GPT or these large language models. So over reliance on these services could definitely harm the humans. So we always consider these tool as a AI collaborators or as a AI like human friendly kind of tools. And it should be like AI and human centric approach. It should not be like we are 100% reliable on these things, and whatever the output we are getting from LLM models, we are just doing blind trust on these applications. So we definitely need to reduce our reliance. We definitely need to place our checks and balances over there, validate the results, and then only we should share that information with the end user. And again, this is the diagram I just wanted to share with you guys. So defense in depth is one architecture we normally follow in software industry, or we normally follow in generative AI application. So here you can see there are many different layers, security layers has been implemented to secure the application. So if you start with the data protection, then we have access management, then application protection, then we have protection at network level, we have protection at infrastructure level, we have threat detection models implemented, policies, procedures, and awareness. So this level of security definitely help the overall application. And even if the one layer is compromised, second layer will be there to protect the harm. If the second layer is compromised, then obviously the additional layers exist over there to help isolate the threat and prevent the detect basically. So so now it's not about just like multi-factor kind of model we talk about. So this is the same kind of approach. It's not one factor authentication or two factor authentication. This is kind of a multi-factor, multi-layer defense system, so we can reduce the chances of threat and loss of our overall application. And one last concept which I just wanted to discuss with you guys, that is related to the private LLMs, because private LLMs are also becoming a very hot topic these days. And when we talk about private LLMs, the primary focus of private LLMs are always the user privacy and data protection. But again, private LLMs are a very challenging concept, very resource intensive concept, or it involves a lot of cost as well. So we definitely need to ask these questions to ourselves. Do we really need private LLM? Do we really have data privacy and security concern? Do we really want to reduce the dependency from any third party model or application? Or we have any regulatory compliance challenges where private LLM is required. But yes, there are few industries like legal industry, healthcare industry, government agencies where private LLM could be required because they have highly sensitive information. So for example, in healthcare, they cannot easily share any patient information with any other user. In legal form, there could be any highly sensitive information, and same as government agencies. So there are few industries there private LLMs are really required, and this is the typical steps to train any private LLM. So first of all, we need a very comprehensive discovery over there, like why we need like private LLM. So we need to do like thorough discovery on our use case. We need to ensure we have the data source available because obviously to train private LLM, we need huge amount of data, and we need to identify the best open source model which we will use as a base model to train it as a private LLM. And the next step is the data preparation step. So once you have identified the use case, you have done with the discovery phase, you need to prepare the data for the LLM training. And then the third step is model training. So once the data is also ready, you need to perform the model training, and once the model training is completed, then we need to do the evaluation. So whatever the response we are getting from the trained model, is it matching our objective criteria? Is it matching our regulation or compliance? Because that was the whole objective to train private LLM. So evaluation is really important. And we also need to consider the concept of ethical and responsible AI in case of private LLM. Because if we are using, let's say, chat GPT, so GPT has already, or OpenAI might have already considered ethical and responsible AI consideration into their model. But when we are training the private LLM, then we need to consider these concepts ourselves, and we need to ensure our private models are ethical, and we are using these models responsibly. And then deployments of these models, because in case of OpenAI or ChatGPT, we get the models deployed, they already scaled. We just need to use their API key. We can send any number of requests and we get the response very fast. But in case of private LLM, or in case of on-prem deployment or any open source model deployment, we need to define the right architecture as well, because latency and throughput is these two very common problems in generative AI. So the first token generation, normally what happened in case of LLM response, it take too much time to generate the first word, and then maybe the subsequent words will be pretty much quick. So we need to define the right architecture to deploy these models. And then the last step is maintenance. So once your models are deployed, and then you need to maintain those models regularly, and you need to keep those models up to date with the latest information or whatever the industry trends. So that's why you may have to be involved with retraining of these models with the new data. You have to bring in the new architectural concepts over there. So maintenance is the last step, but the not the least one. So that's all from my side, guys. So this is a little bit about myself. So now I can open the house for question and queries. If you guys are having any following questions, please feel free to ask, or put it into the Q&A section. So in case anybody is not having any question and queries, then I think we can wrap up this session. So thank you so much, guys, for joining me today, and have a good upcoming days. Feel free to chase me on LinkedIn or follow me on LinkedIn for any question and queries you have in terms of generative AI applications or large language models, or if you guys need any consultancy or any help in terms of end-to-end generative AI applications. So whenever you guys are having any question, feel free to ping me on LinkedIn.
Hi Ankit, I think we have some questions in Q&A column.
Oh, I think they are in chat, not Q&A. So
In Q&A also.
Okay. In Q&A, maybe I joined late. Okay, Tom is there, the recording. Neeraj. What strategies can be employed to optimize the performance of GenAI model in production? So I think this is the first question from Ishita, I can see. Yeah, so Ishita, as I mentioned, we to improve the latency and throughput, we have two different techniques. So one is the inference engine and one is the inference server. So to improve the latency and throughput specifically, we need to follow the LLM engines, because LLM engines having the capabilities for KV caching, page attention, continuous batching kind of concepts. So if we implement inference engines correctly, we get much better accuracy. That is the first step. And second step is obviously at an infrastructure level, what GPUs we are using, because LLMs consume so much memory, and most of the time you guys will face out of memory error in case of LLMs deployment. So second step is always you guys need to have capable GPUs based on and according to your traffic and according to the volume you have. So first is the application level inference engine. Second is the infrastructure level GPUs capabilities and right architecture. Deployment and what made them. Yeah, so if you ask for the successful example, so chat gpt is the successful example. So I don't feel like anybody of you feel any latency or throughput issue in case of chat gpt. So chat gpt is a successful example of deployment, and it comes with great performance and optimization or efficiency. So yes, ChatGPT is a successful example. So I think next question is from Neeraj, that is related to the data security, ethics, and sustainability, how to tackle the hallucination. So for hallucination specifically, Neeraj, so RAG is the best way, because hallucination means the LLM doesn't have the right information to respond to your query. So to remove the hallucination, so we need to ensure that model is having the right information. Model is already having the source of correct information, so that's how the model will be able to generate correct results. And for data security and ethics, for data security, yes, we need to implement the different level of security guardrails. As I mentioned, there will be a different level of security: application level security, network level security, infrastructure level security, access level security. So these are different levels of security we need to implement, and we need to store the data, especially in case of RAG. We need to make sure our data is stored in a secured way. Normally what happens, we just create one simple vector DB and we just throw the GBs or MBs of data directly into the vector DB. That is not the correct way. We need to make sure our data is encrypted. We need to make sure we don't have a highly sensitive information stored in an unsecured way. So these are the different layers we need to implement to ensure the security of overall GenAI application. And then the next question from simply, what are the key factors to consider when deciding to move a Gen AI or LLM project from POC to production? That is a great question. I think Prabjot posted this question on a behalf of some other candidate. So the main thing is the right value proposition clarity. Experimentation is way easier in generative AI application, but when we think about taking that experimentation to production, that brings so many strategic challenges plus technical challenges. So according to me, the first question we need to ask ourselves, what is the value proposition any generative AI application is bringing to you? Because even in the recent article, Gartner mentioned that over investment in the generative AI application could be harmful for the businesses. And this is currently, it is happening. Every business, every industry is looking for the generative AI, but most of the businesses doesn't have the clarity on value proposition. So if we are investing into any Gen AI application without the clarity of value proposition, without the clarity of the end results, we will definitely lead that project to failure. And one another hype over here is like we think Gen AI is a sole solution. That is not the case. Gen AI is not a sole solution. But if we combine Gen AI with the other kind of solutions, then it deliver more values. So for example, you have Gen AI model with your digital transformation journey, or maybe you have Gen AI model with your machine learning model as well. At the moment we are expecting Gen AI models to do everything. That is not the right way to take the Gen AI application. So the value proposition clarity, the use case clarity, these things are really important to think and answer before deciding to go to POC to production. What is the minimum specification and speed of GPU is required? That completely depends on the use case, Ishita. So there is no defined GPUs because in in LLMs we have a different size of LLM models. Few models which are small in size and trained on less number of parameters. On the other hand, a few models are very large and trained on billions and trillions of parameters. So it's 100% depends on the model you choose. If you have a, let's say, specific use case, you can pick any small language model and that you can deploy to the smaller GPU. But let's say if you pick a model, something like Llama 3 or Mistral large model, then you need high-end GPUs. So it completely depends on the GPU, it completely depends on the model you choose, and accordingly you need to decide the GPU capabilities. Plus the traffic you have. So if you want to cater, let's say, chat GPT kind of volume or traffic, then obviously maybe one GPU will not be sufficient. Maybe you need hundreds or thousands of GPUs up and running at the same time. So it completely depends on the use case and volume. What are the best practices for scaling a generative AI and LLM model from in terms of infrastructure and resource management? So Abhinav, if I understand your question correctly, so I think you're also talking about optimization in terms of hardware infrastructure, GPU. Okay. Yeah, so as I mentioned, again, it depends on the model size. We cannot optimize the GPU. Obviously, we will have to optimize the model. So let's say you are using 7 billion parameters of model. So there are few model optimization techniques like I mentioned, LoRa, XLoRa. So these are some pefting techniques, and using these techniques, you can optimize the model size. And there are some other techniques also available like model pruning, quantization. So using these techniques, you can reduce the model size And if your model size is reduced, then obviously you need less capabilities of hardware to deploy your models. So again, according to your application, according to your use case, we need to figure it out what is the best model, what is the best size of model we required, and accordingly your infrastructure will be designed. So I think I answered all the questions from the chat. Prabjot, can you help me if I missed any question?
No, sir, I think we are done with all the questions.
Okay.
Yeah.
Okay, but still, if you guys would have any more question and queries, feel free to drop on LinkedIn. So I will definitely get back to you guys, and I will ensure whatever is my best knowledge I can share with you guys. So feel free to ping me on LinkedIn.
So guys, thank you everyone for joining our webinar. And I hope this webinar will be insightful for you. And if you are a CXO and you are interested in GenAI solutions, I will share a Calendly link with you. You can schedule a meeting with the team over there, and make sure to join our LinkedIn page to stay updated with our upcoming webinars and all the news over generative AI and latest updates over generative AI. And along with that, you can also subscribe to our newsletter from our website. Just enter your email and click the subscribe button, and all the recent emails and blogs related to Gen AI, machine learning solutions, and latest news will be sent to you over the mail. So I'm sharing the Calendly link over the chat. So if you have any query related to Gen AI solutions, you can just schedule your meeting with the team, and one of our experts will get back to you as soon as possible. So thank you, everyone.
Thank you so much, guys, and have a good night and good day as well. I think some people joined from some other time zone as well. So good night and good day to you guys. Thank you.
Thank you. Thank you, Ankit, for sharing all the information.
Yeah, pleasure.
Thank you, team.